Hello students, myself Dr. Padmaja, Associate Professor, Institute of Aeronautical Engineering, Hyderabad. In this video, we are going to learn how to do problem solving using sliding window approach. Now, first of all, we have to know what do you mean by sliding window approach. Now, in a sliding window, normally the input will be an array or list or a string, and we have to take a window size of k and we have to slide over to get the desired output. Okay, suppose example, we have to find out the maximum score of a subarray. Okay, then we have to divide the original array into subarrays of size k, that we normally call it as window size. And then for each window we have to find it out the sum of all elements, the sum of the elements in that subarray, and we will check whether it is the maximum score or not. Otherwise, we'll take the next slide. Again, we'll find out the maximum score and we'll compare with the earlier score. This way, the window will be slided until we reach to the end of the list. Okay. Now, sliding window is one of the most popular approach in computer programming. And today, we will learn that where we can use the sliding window approach for solving which kind of problems, and we will discuss some problems with its solutions. Now, let us discuss the first problem, find the k beauty of a number. Okay. Now, let us understand the question first and let us analyze whether sliding window approach will be appropriate or not. If appropriate, then how to solve the problem using Python. Now, the question is given as the k beauty of an integer num is defined as the number of substrings of num when it is read as a string that meet the following conditions. Now, what do you mean by this? Originally, you have been given an integer num. You have to convert that number into a string and you have to find it out the substrings of a particular length k, and you have to check whether those substrings are, if converted into the numbers, then they are divisible or they are divisors of original number or not. Okay, so there are two conditions. You have to make substrings of length k, and whether the substrings, if converted into integers, then whether it is divisor of num or not. Now, given integers num and k, input is your a numbers array and the k value, which we call it as window size. Find the k beauty of a number. Now, there is a note that leading zeros are allowed, okay, and 0 is not advisor of any value, right? So, a substring, what is a substring is given? A substring is a contiguous sequence of characters in a string. This is just a definition of substring is given, right? Now, let us understand the test cases first. Now, the input is given as the number 240, okay? So, the number is given as 240. Now, what we will do, we will convert this number into string 240. It is given in the question. You have to, the integer number is defined as the number of substrings of the num. So, if you want to find out the substring of the original number, then you have to first convert the number into substrings. Right. The value of k is given 2. That means you have to form substrings of length 2, which we call it as window size also. Window size is nothing but the substrings or subarrays or sublist of particular length. So, here k value is equal to 2. So, what we will do, we will make the first substring as 24 and the second, after sliding, the second substring will be 40. So, window size of k is equal to 2. With the length of 2, we can form two substrings from the original nums array. One is 24, 24 as a substring and 40 is a substring. 40 is a substring. What we will check? So, we have divided the substrings of length k. Yes. Then, we have to check whether it is a divisor of num. So, what is my original num? 240 is my original number. How will I check? A string can be a divisor of an integer? No. So, I need to convert it back into integer. So if I'll convert it back, it is 24. And if I'll convert it back, then it is 40. So string to integer again I have to convert. Then what I have to check, whether number divisible by the substring, int of substring, this is converted into integer of substring, is divisible or not, is 0 or not. So 240 modulus 24 is equal to 0? Yes. If it is equal to 0, then take a variable beauty or k, whatever, or k or count or whatever, and you do count plus plus. So 1 beauty, you got it. Again, next time, 240 divisible by 40 or not? Yes, it is divisible. Yes. Then our count or beauty variable will be again incremented to count plus plus or beauty plus plus. That is 2. So how many beauties are there? Which is nothing but the count value. So there are 2 beauty in this example. Now if I talk about the second example, 430043, and we have to form substrings of length 2. So we have to form substrings of length 2. Now what we will do? First we will convert this number into a string. So you can see here it is a string. 430043 is a string now. Now you form substrings of length 2. So 43 is a substring. So 43 is a substring first. Right? Convert that into integer 43. Is it a divisor of the original number? Yes. So we will do count is equal to 1. Beauty count we are incrementing to 1. Next number, slide the window of length 2. So it is 30. 30 is a substring. Then convert into integer 30. 30 is a divisor of this number? No. So count cannot be incremented. Next, 2 zeros is a substring. Okay. Then 0 is not a divisor of this number. Okay, fine. Then 04 is a substring. Then 4 is not a divisor of this number. Yes. Then 43 is the substring. 43 is converted into integer 43. 43 is a divisor of this number. Yes. So count will be incremented. So count is equal to 2. So therefore k beauty is equal to 2. There are 2 k beauties for the given number. So I hope you understood how to analyze the question first with the test cases. Now let us write down the code for finding the k beauty, and we will test with any test case. Suppose we will take number is equal to 240. Now understand the code first. Let us take nums is equal to 240. Right? Now, so we are passing the number over here and the value of k, and k value is equal to 2. It is given. Right. These two are passed as a parameter. This is 2 and this is 240 as a number. To count the number of k beauties, we have taken a variable count is equal to 0. Now what is the first step? We have to find substrings. So we have to convert the number into substrings. So what we will do? We will convert this number into substring 240 using the str function. So now my s is equal to 240 is a string. Right? Now then how to form substrings? So for finding substrings, let us run a loop till the end of the string. So from where we will start? For I in the range of from k. K is equal to how much? 2 comma. Length of this string is how much? 3 plus 1 is 4. That means k value will range from 2 and 3. K value range from 2 and 3. Okay. So when k value becomes 4, the loop is going to stop. Right. Now first time k value is equal to 2. So first you have to slice it down to find a substring. So what we will do? We will find it out the divisor. So what is divisor? This divisor will convert into integer. So divisor is nothing but s of I minus k to I. Okay. So what is that? Integer in the substring s. What is the value of I? So I value is first time. This is I value. I value is first time 2. K value is also 2. 2 minus 2 colon 2. So which is nothing but integer s of 0 colon 2. Right? So we have to slice it down from 0 to 2 up to 2. Means 0 and 1. So in this 0, 1, 2. So we will slice it down at 2. So what is my substring that I got? is 24. That I am converting into integer and that I am calling it as divisor. So my divisor is equal to 24. Right. Right. Now this divisor I have to check whether it is divisible by num or not. So if the divisor which you have got, so I got 24 is not equals to 0. Yes, it is true. And number modulus divisor, that means 240, the number modulus divisor is 24 is equal to 0. That means it is properly divisible. Yes, it is divisible. So we'll do count is equal to count plus plus. So my count value becomes 1. Right. Second time I value is equal to 3. Again you do. So it will be I minus k to I. So it is 3 minus 2 up to 3. So 3 minus 2 is 1. 1 to 3. My slice will be 1 to 3. So 1 to 3 is nothing but this part 40. So second time my divisor will be integer of, it is 40. So which is converted into 40. And 40 is not equals to 0. Yes, not equals to 0. And number modulus divisor 240 modulus your 40 is how much? Is equal to 0. Remainder is 0. Yes. So counter will be incremented. So count value is equal to 2. Third time my loop is going to stop and I will return the k beauty of a number as the count value, which is nothing but 2. I hope how to find it out k beauty of a number using sliding window approach is understood. Now, let us understand the next question, maximum erasure value. You are given an array of positive integers, nums, and want to erase a subarray containing unique element. This is very important. Now, the score you get by erasing the subarray is equal to the sum of its elements. Now, return the maximum score you can get by erasing exactly one subarray. So, what you need to find it out? You need to calculate the maximum score and for the subarray which you want to erase. Right. Now, the definition of subarray is given. An array B is called to be a subarray of A if it forms contiguous subsequence of A, that is if it is equal to A of L plus 1 and so on up to R for some L comma R. So this is simply the definition of what do you mean by a subarray. So we need not focus on much on this part. So we have to first think about the approach sliding window. We have been given an integer nums array of all positive integers. We have to find it out these subarrays and we have to slide it down. The subarray, if the subarray contains all unique elements, then we have to find it out the maximum score of that subarray. Okay, and we have to decide which subarray we have to erase. So the subarray which has maximum score should be erased. Right. Now let us understand the test case. Originally nums array is 42456. Okay, k value is not given. Let us take k value of size 4. That means this is my window size, sliding window size. I'm just assuming over here to make you understand. Now, what is my array? It is 42456. This is my nums array. Now, if I'll take a window size of this much, 4256. Okay, this is my first window. You can see here, this 4 and 4 are the repeated element. So, what is given in the question? Question is to find out the subarray containing unique elements. So, I cannot consider this window size. Now, next time if I'll consider the window size of 4, it is 2456. So, 2456 is a window of unique elements. So, this is a subarray. Now, what is the score of this subarray? Score of this subarray is 11 plus 4, 11 plus 6 is 17. So, the maximum score is 17 possible. Okay, right. So, the optimal subarray is here 2456 with the maximum score 17 possible here. Now, let us understand the second question. Now, In the second question also window size is not given. If I'll take window size is equal to 3 as the window size, then how to find out the maximum score of any window or subarray containing only unique elements. Now, if I talk about the first one, 5 to 1, containing all unique elements, what is the score? 5 plus 2 plus 1 is 8. Right. If I slide it down to the next window, 2, 1, 2. So it contains repeated elements, so I cannot consider. If I talk about the third window, 1 to 5 contains unique elements, score is 5 plus 2 plus 1, it is 8. Then if I'll consider 2, 5, 2, then it contains repeated element. If I consider 5 to 1, again the same window frame I am getting with the score of 8. If I'll consider 2, 1, 2, repeated element is there, I cannot consider. If I consider the last frame, it is 1 to 5, again it is containing unique elements and the score is 8. So here the optimal subarrays are only two which is coming repeatedly, either 5 to 1 or 1 to 5, and the maximum score is 8. Okay, so this problem can be easily solved if k value is given in the question, that is the window size, so that we can easily apply the sliding window approach for each subarray. We can find it out the maximum score and we can check whether it contains unique elements or not. But in the question k value is not given. Then how to solve the problem? So to find out the optimal subarray and the maximum score, we can take the help of a set concept in Python. So let us understand how to solve this problem in Python. Now 4 to 4, 5, 6 is my nums array. So let me write here 4 to 4, 5, 6. And for this array, let me write down the index number 0, 1, 2, 3 and 4. Right. Okay. So we are passing this particular nums array to my maximum unique subarray method, and we are expecting the score which is an integer. So this is just my return type. Now to solve this question, I am taking a set S1 which is initially empty. So I am writing here like this. Now I am taking a variable answer is equal to 0 and I have to find it out this sum initially 0 and I is equal to 0. These are the initialized parameters. Right. I am taking another variable j in the range of length of nums. What is length of nums? Is 5. 5. So j will take up the values 0, 1, 2, 3 and 4. Okay. First time j value is equal to 0. Now let us analyze this solution. Now, while nums of j is in S1, nums of j is how much? Nums of j is equal to 0. So, what is the value? It is 4. 4 is in set S1? No, it is not in set S1. So, we will come out of this while loop and we will add that number 4 to the set. And also we will add to the sum. We will add to the set and also we will add to the sum to find it out the maximum sum, which is 4. Okay. Now you compare which is maximum. So answer is equal to max of answer comma sum. So if you will check here, then it is max of answer is initially 0 comma sum is 4. So you will get 4. Right. First iteration is over. Now in my second iteration, what is the value of j? J is equal to 1. Now what is nums of j? Nums of j is 2. 2 is in S1. Set S1? No. So again come out of the while loop. Add it to the set. So I'll add 2 to my set and also to my sum. So 4 plus 2 it becomes 6. Find out the answer which is the maximum one. So let me write. It is max of. Earlier answer was 4, comma. Now my sum is 6. So it is 6 again. Right. Third time. In my third iteration, j value is equal to 2. So for nums of j, what is the value we are getting? It is 4. Now, nums of j is in S1. 4 is there in S1. Yes, it is true. So if it is true, then set should always contain unique elements. So we have to remove the previous 4. If you want to insert the new 4, then you have to remove the previous one. So what we will do? we'll do S1 dot remove of num sub I. What is the value of I? I is equal to 0. So num sub 0 is how much? 4. 4 we have to remove it. So this 4 we are going to remove it. And also you remove from this sum. So 6 minus 4, again we are removing, it is 2. Okay. Second time. Now I becomes 1. Now again you check what is the value of j? J is equal to num sub j. Num sub j contains 4. 4 is in S1? No, now it is not there because we have removed it. Now again you add it. So if it is not there, again you have to add it and add it to the sum also. So again 2 plus 4 becomes 6. And is there any change to the max value? No, earlier maximum was 6, now also the sum is 6. So there is no change to the max value or answer. Okay, fine. Now next time j is equal to 3. What is the value at num sub j? Is 5. 5 is in S1 in the set? No. So we have to keep 5 here. Right. Now coming out of the while loop, add it to the set, add it to the sum. So 6 plus 5, it becomes 11. Now what my answer? Answer will be changed. So answer will be max of, earlier answer was 6 comma sum is 11. So it is 11 now. Right. Fine. Now last iteration j is equal to 4. What is the value at num sub j? It is 6. So is it there in the set? No. So we'll add it to the set. Right. Answer is equal. So sum is equal to sum plus 11 plus 6 becomes 17. And here the max will be changed to earlier sum max of 11 comma 17. It is 17. Right. So all my iterations are over, and what is my answer? Is nothing but the maximum score 17. And what is the unique subarray? It is 2, 4, 5, 6, which is there in the set. This is the unique subarray. In this question, they have asked to print the maximum score of the subarray, which contains unique elements. So the score is 17. Maximum score is 17. So similarly, you can try with the second test case and trace it down and understand what is the solution. Now, let us move on to the third problem. Third problem is substrings of size 3 with distinct characters. Now, let us go through the question first and understand the question. A string is good if there are no repeated characters. Given a string S, return the number of good substrings of length 3 in S. Now, from the question you can understand that input is given as a string. Input is a string. You have to find it out substrings of a particular length. Now, when such kind of problems are given, input is a list, you have to find out sublist. Input is an array, you have to find out subarray. Or input is a string, you have to find out substring of a particular length. Then you need to understand that for these kind of problem, I have to use the sliding window approach. Right. In this case, what is given in the question? You have been given a string S. Return the number of good substrings. So, what is a good substring? If the substring has no repeated character, then it is a good substring. So, you have to find out such substrings which has length 3. So, window size is also given as 3 only. Note that if there are multiple occurrences of the same substring, every occurrence should be counted. That means the same substring may be coming repeatedly, but every occurrence you have to count. Then it is given a substring is what? The definition of substring is the last line. A substring is a continuous sequence of characters in a string. Okay, fine. Now let us understand the test cases. What is the first test case? Is X, Y, Z, Z, A, Z. This is my string. Now, it is given in the question to make substring of size 3. So, X, Y, Z is my first substring. So, my first substring is X, Y, Z. Right. Is it containing all unique elements? Yes. Its length is 3. So, it is a good substring. So, you can take a variable good substring. So, make it good substring is equal to 1. Initially good substring is equal to 0. Now next time you slide over this string. Next time YZZ is my substring. Now there are repeated characters, so it is not a good substring. So we will not increment good substring variable. Next time it is ZZA. It is ZZA. So again repeated character is there. So I will not increment my good substring. Next time it is ZAZ. So it is also containing repeated character. So it cannot be a good substring. So I am not going to increment my good substring counter. So finally, how many good substrings are there in this string? Only there is one good substring of length 3 is possible. Right? But 4 substrings you can make it. Right? Now, similarly, the second question is AA, BA, BCA, BC. Okay. Now, if you will divide into substring of length 3, so this is AAB containing repeated character, ABA containing repeated character, BAB containing repeated character, ABC containing unique. So, good substring is 1. Okay. ABC. Then contains BCA is another good substring. So, it is 2 now. Now, CAB is another good substring. So, it becomes 3 now. Then ABC is again good substring. So, it becomes 4. So, how many good substrings possible? 4 good substrings are possible. But how many substrings you have divided? 7 substrings you have divided. So, in this way, we will reach to the end of this string and will form the good substrings of length 3. So, hope this question is understood. Now, let us understand how to write down the solution for this problem. Now, let us take the string S is equal to X, Y, Z, Z, A, Z. Okay. Let us check it. Yes. This is my string. So, input is a string S and return type is how many good substring possible, which is nothing but integer value is a return type. Now, to count the number of good substrings, you have taken a variable count is equal to 0 and let us find out n is the length of this string, which is nothing but 6. Okay. Now, if the length of this string is less than 3, is it possible to make a good substring of length 3? No. So, we will simply return 0. Okay. If the string length is less than 3, then no such good substrings are possible of size length 3. Right. Now, if it is more than 3, then like in this example, the substring of length 6 is given, then how to solve it? For I in the range of n minus 3 plus 1. Why n minus 3 is given? Because when the pointer reaches here, then the last substring is possible. Okay. So, it is n minus 3. Total length minus 3. Up to that we have to run our loop. Plus 1. Because next time it is going to stop. Okay. So, what is the value of n? It is, what is the length is 6. 6 minus 3 plus 1. It is 4 times. Okay. So, I will take the values as 0. Okay. So, I will take the values as 0, 1, 2 and 3. So, 4 times my loop is going to run. Right. So, how to make this substring? So, first substring I am making is S of I is equal to 0 to I plus 3 is 3. So, 0 to 3. So, if you take your string X, Y, Z, Z, A, Z, then this is the string 0, 1, 2, 3, 4, 5. These are the indexes. So, 0 to 3 means 0 to 2 is the first substring. So, which is nothing but X, Y, Z. Right. Now, we will convert this into a set. Then what will happen? It will be like this X, Y and Z. Now, if I will find it out, the length of the set, then it will be 3. If length is equal to 3, that means all the characters are unique here. Then I will do my count plus plus. So, it is a good substring. Okay. Now, the definition of good substring is you should not contain any repeated characters. Next time. For I becomes 1. So, again find out the substring S of 1 colon 4. I to I plus 3. It is S of I to I plus 3 always. So when I becomes 1, I plus 3 is 4. So what is the substring? It is YZZ. Containing, convert this into a set. So it will contain only Y and Z because another Z is repeated. So it cannot take both. Right? Now, if you convert this set, what is the length? What is the length of the set? It is only 2. So, if length is equal to 2, it is not counted as a good substring. So, do not increment the counter. Again, this process you have to repeat till you reach to the end of the. So, it is YZZ. Third time it will be ZZJ. It is length is 2. Again, ZZ. Again, its length is 2. So, 4 times this loop we are going to run. And finally, my counter value is only 1 because only one good substring is possible. That is the first one, XYZ. Okay. So, in this program, we have learned how to make substring sub size 3 with the sliding window approach. Now, let us move on to the next problem. Now, the next question is finding the minimum difference between highest and lowest of K-scores. Now, what is the problem statement? Let us understand the test cases. Then we will move on to the solution. Now, you are given a zero index integer array nums, where nums of I represent the score of the ith student. You are also given an integer k. Pick the scores of k students from the array so that the difference between the highest and the lowest of the k scores is minimized. Right? That means the nums array contains scores of each student. If you will find it out the highest score and the lowest score of a particular subarray, the difference between the scores should be minimized. Okay. Return the minimum possible score. You can see here in the first test case, there is only one score, one student score. So, the highest score is 90 and also the lowest score is 90. If you will find out the difference between highest and lowest, it is always 0. So, minimum possible difference is 0. If you understand the second test case, there are 4 student scores are given. 9, 4, 1, 7 are the scores of 4 different students. Now, K value is given as 2. That means you have to take 2 scores at a time to find it out which is highest, which is lowest, find the difference and check whether it is minimum or not. Now, if I'll take 2 scores 9 and 4, highest score is 9, lowest score is 4, so it is 5. If I talk about 9 and 1, so here the score combination is 9, 4. Second time 9 and 1 if I take, so 9 minus 1 is 8. If I take 9 and 7, the difference is 2. Next, if I'll take 4 and 1, 4 minus 1, the difference is 3. If I'll take 7 and 4, then the difference is 3. If I take 7 and 1, the difference is 6. Okay, out of all the scores, the minimum possible score is 4. So, they have given there are 6 ways to pick up the score of the 2 students. So, this is one approach. Another approach can be sliding window approach. What you will do, suppose my nums array is given as 9417. Instead of doing this way, I can make the nums array as sorted. So, nums.sort method if I use, then it becomes 1, 4, 7 and 9. And k value is already given as 2. Window size is given. So, what I will do, I'll slice it down. The first subarray, that is 1 and 4, and I'll find it out the difference. Difference is, I'll take the absolute difference between 1 and 4. 4 minus 1, it is 3. Okay. Second time, I'll take the second slide. Okay. I'll find it out. The difference is absolute difference of 4 minus 7. 4 minus 7. It is again 3. So, what is the minimum score between these two? 3 only. Again, I'll take down the third slide. I'll find it out the difference. It is ABS of 7 minus 9. It is 2. So, out of these 3 scores, which is the minimum score? Is 2. So, 2 will be my answer. Okay. So, that is another approach. So there are multiple approaches to solve, but let us understand and solve using only sliding window approach. So let us write down our nums is originally given 9417 and k value is equal to 2. So how to solve this question? Now nums array is given, k value is 2 and nums array is given 9417. Now if any array is given of length 1, like in the previous example, there is in the first test case it is given 90, which is only one score, one student score. So if the length of numbers array is less than equal to 1, that means it may contain nothing, empty, or it may contain only one score, directly the difference will be 0. Right? Otherwise, if it is length is more than that, then we have to sort it out. So after sorting, my array looks like 1, 4, 7 and 9. Right? Now, what is D? D is a very large value. I am just setting it. Okay? So that I can compare the which is the minimum value. So D is a very large value. Float of infinitive is written in Python to set D to a very large value nearer to infinitive. Right? So, how to find it out? The substrings or subarrays and check their highest and lowest score difference so that the score will be minimum. For I in the range of length of nums minus k plus 1. What is length of nums? Is 4 minus k value is 2 plus 1. So it is 3. So I will range from 0, 1 and 2. So this loop is going to run 3 times. How many substrings are possible? 1, 2 and then 3. So I am going to run my loop 3 times. Now what is my first difference? Difference is nothing but ABS of nums of I. So it is nums of I is 0 minus nums of I plus k is 0 plus k is 2 minus 1 is 1. Okay. So what is there in nums of 0? We have 1 minus nums of 1 we have 4. We are talking about the sorted array nums. So absolute difference between is 3. This is my difference. Okay. How to find it out? D? D is nothing but minimum of this one formula. Difference is 3, comma. D is a very large value. So if you will compare which is minimum, 3 is minimum. Right? Similarly, second iteration. I have to find out difference which is absolute of I becomes 1. So it is nums of 1 minus nums of 2. Nums of 1 is how much? This is 0, 1, 2, 3. Nums of 1 is 4. So it is ABS of 4 minus 7 is 3. Okay. Now D is nothing but minimum of earlier difference is 3. Now difference is also 3. So minimum is 3 only. Now in the third iteration, find out the difference. Difference is I value is equal to 2. So it is ABS of nums of 2 minus nums of it is 3. So I am talking about 7 and 9, last one. Okay. So it is ABS of 7 minus 9, which is 2. So difference is 2. What is D value? It is minimum of earlier difference was 3, comma. Now difference is 2. So which is minimum? Minimum is 2. So D contains the minimum score difference which is 2. So in this way we can solve. The answer will be 2. So minimum difference between highest and lowest k scores is 2. Now the next problem that we are going to discuss is called subarray product less than k. Now let us understand the problem statement first. Given an array of integer nums and an integer k, return the number of contiguous subarrays where the product of all the elements in the subarray is strictly less than k. Okay. Now, you have been given a nums array containing these numbers and product should be strictly less than k. Okay. So, how many subarrays are possible from 10, 5 to 6? Okay. Individually, 10 is a subarray possible, single element subarrays, 5 is a subarray, 2 is a subarray, 6 is a subarray possible. Then you can combine 10 comma 5 is a subarray possible, 5 comma 2 is a subarray possible, then 2 comma 6 is a subarray possible. Then we have subarray 5 to 6 is also possible, right? But if you will take this subarray 10, 5, 2, it is not possible because the product of these elements is exactly equal to 100. So, which is not less than or equals to, not less than, which is not less than my k value. K value, which is also 100. This is my k value. Okay. So, how many subsets are possible? So, we have 8 subarrays are possible. So, you can take all the combination. So, 10, 5, 2, 6, single element. Then 10, 5, 5, 2, 2, 6, then 5 to 6. So, these many subarrays are possible whose product of the elements, if you 6, 5 to the 10, 10 6 is 60. So, it is less than 100. 2 into 6 is less than 100. 5 into 10, 210, which is also less than 100. So, these many subarrays are possible where the product is less than 100. Okay. But 10, 5, 2 we cannot take because the product is exactly equal to 100. So, which is not strictly less than k. Right. In the second example, there is a nums array containing 3 elements, 1, 2, 3, but k value is given as 0. So, if you take any subarray, either 1 or 2 or single element or double element, 1, 2 or 2, 3 or 1, 2, 3, the product of these subarrays is never less than 0. It will be a valid positive integer. So, that's why the output is 0. Hope this question is understood. Now, let us understand how to write down the solution of it. So, let us take 10, 5, 2, 6 is the input nums array. So, what is my nums array? Is a list of integers. Okay. And k value is given as 100. So, here k is not a window size. K is just a constraint to check whether the product is less than 100 or not. Right. And how many such subarrays are possible? This is my integer return type. Now, if the second test case is there where k is equal to 0. If k value is given as less than equal to 1, then we have to return 0. Okay. That means any integer or any list with some valid integers cannot have 0 as the product. So, that's why this is the first test case satisfied. Okay. From left and right pointer we are going to use. Initially left is equal to 0. Answer we are going to find it out, which is initialized to 0. And we are going to find it out the product, which is initially 1. Right. So, for right in range of length of nums. So, what will be the value of right? What is length of nums? Is 4. So, right value will be 0, 1, 2 and 3. First time right is equal to 0. So, what is my current value? Is current value is equal to current value multiplied by nums of 0. What is there in nums of 0? This is 0, 1, 2, 3. It is 10. So, it is 1 into 10. Product current value is 1 into 10. It is 10. So, my product is 10. Now, we have to check whether it is greater than equal to k. So, current value is 10. Is greater than equal to 100? No. So, it is false. So, if it is false, you come out and form the answer. Answer is answer plus right minus left plus 1. So, answer is initially 0 plus. What is the value of right? Right is 0. Left is also 0 plus 1. So, how many subarrays possible with only one number? We have considered till now only 10. So, with that only one subarray possible. Right. Let us go for the second one. So, now right becomes 1. So, what is my current? Current is equal to earlier current is 10 into nums of 1. What is there in nums of 1? It is 5. So, it is 10 into 5. It becomes 50. Okay, 50 is greater than equals to k? No. So we'll again form our answer. Answer is equal to, earlier answer is 1 plus right is 1 minus left is 0 plus 1. So it is 3. That means with two numbers, 3 maximum 3 sub-arrays possible. Right. Now in my third iteration, what is my current value? In my third iteration, right is equal to 2. 2 means we are nums of 2 is 2. Okay. Product is now current value is 50 into nums of 2. So 50 into 2 is 100. Now check current value 100 is equal to 100. Yes. If 100 is equal to 100, then what we have to do? We have to subtract from, means you have to divide from current. So current is equal to current value is how much? It is 100 divided by integer division by nums of left. Nums of left is how much? 10. So current becomes 10. Okay, and left becomes left of 1. So left plus plus, so it is 1. Okay, second time current is now changed to 10. 10 is greater than equal to 100. No. So we'll come out. And answer is equal to, we'll form answer. With three numbers 10, 5, 2, how many sub-arrays possible? So answer is equal to, earlier answer was 3 plus right is nothing but 2 minus left is 1 plus 1. So 3 plus 2 it becomes 5. So 5 such sub-arrays possible whose product is less than k. Now check right value is equal to 3. If right is equal to 3, find out the current. So what is my current value? Earlier current value, now earlier updated to 10 into nums of 3 is nothing but 6. So 10 into 60, 6 it is 60. Right? Okay. Now here 60 is greater than equals to 100. No. So current is equal to current. So what we will do, we'll come out and we'll form the answer. Answer is equal to, earlier answer is 5 plus right value is nothing but 3 minus left is 1 plus 1. It is how much? It is 5 plus 3, 8. So these many sub-arrays of product less than k is. Okay. So I hope you understood the problem and you understood the process of solving this. In this video, we understood how to apply sliding window approach in solving various computer problems. Hope this video you have liked it, you understood. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.